Okay, number 9, we have a series, pretty complicated series, and we need to find its interval of convergence. So remember that when you have these interval of convergence questions, nearly 100% of the time you're going to be using the ratio test. And you can tell that here too because you do have exponential functions, so you know the ratio test is what we're going to do here. So we want to find for which values of x does this converge. Now, using the ratio test, we know if we want it to converge, the ratio test has to give us a result less than 1. So let's try that. So ratio test, we do absolute value of the n plus 1th term. So we have 3 minus x to the n plus 1 over root n plus 1 times 2 to the n plus 1 times, we're going to do the reciprocal of the nth term. So we have square root of n to the n, 3 minus x to the n. We want, as the limit as n goes to infinity of this, we want this to be less than 1. So let's see what we can cancel out here. First of all, we don't need the absolute value bars. Everything in here, or actually we do around 3 minus x, but everything else is going to be positive anyway, so we don't really need to worry about that. Let's see what cancels out. 2 to the n plus 1, 2 to the n. That's going to cancel it out and just leave a 2. 3 minus x to the n plus 1 over 3 minus x to the n. That's going to cancel out, and that's just going to leave us a 3 minus x. Now, like I brought up in one of the earlier problems, when you're doing the ratio test and you have something that's not an exponential or factorial, in this case like the radical n, as n goes to infinity, radical n and radical n plus 1 are the same thing. That ratio, they're essentially going to cancel out. They're canceling out again because you're going n to infinity. The limit of, in other words, if you just isolated that part out and did the limit as n goes to infinity, that limit is just going to be 1. So what we're left with is we have absolute value of 3 minus x over 2. And we want it to converge, so we know that has to be less than 1. So let's figure out what this is. If we multiply the 2 over, and we can do that because 2 is just a positive number, absolute value of 3 minus x has to be less than 2. In other words, 3 minus x has to be in between 2 and negative 2. So let's solve that for x. We can subtract 3 from each part of that inequality. So we would get negative 5 is less than negative x, which is less than negative 1. And finally, we can divide by negative. Remember, you have to flip the signs of the inequality if you do that. So this is going to be that x is in between 1 and 5. So we know that our interval of convergence is going to have to be from 1 to 5, but we don't know, should we be putting parentheses or brackets on these? We don't know what's happening at our endpoint, so let's check that out. So when x equals 1, when x equals 1, we get 3 minus 1, which is 2, to the n. So if you notice, the function part of our series here becomes 2 to the n over square root of n 2 to the n. These 2 to the n's cancel out, and we just get 1 over square root of n. Now 1 over square root of n is just a p-series that does not converge. So therefore, x equals 1 diverges. So we know we have a parenthesis on 1. 1 does not converge. What about x equals 5? If we plug in 5, this is going to become 3 minus 5, which is negative 2 to the n. In other words, that could be separated out as negative 1 to the n, 2 to the n, over square root of n, 2 to the n. Again, the 2 to the n's cancel out. What's the difference? This time we have 1 over square root of n, but it's alternating. That's a big difference, because remember, for the alternating series test, the restrictions are much less. So this will converge if the 1 over square root of n is always decreasing and the limit goes to 0. So is 1 over square root of n always decreasing? Definitely, because as n gets larger, the square root of n gets larger, and if the denominator is getting larger, the series is always getting smaller. So, is it getting smaller as you increase n? Yes. Is the limit 0 as n goes to infinity? So what's the limit as n goes to infinity of 1 over square root of n? Well, square root of infinity is still infinity, and 1 over infinity gives you 0. So yes, it's always decreasing. Yes, its limit is 0. Therefore, this one converges by the alternating series test. So when x equals 5, we have a convergent series. When x equals 1, we had a divergent series. So our interval of convergence is everything between 1 and 5, not including 1, but including 5. So we have our interval there, which on your test is answer choice E.